controls and regulation of the cell cycle. Just to put it simple, neoplasms are either benign or malignant. طبعا في بعض tumors they have intermediate behavior between benign and malignant. We're not discussing these now. We just want to focus on what we call benign and what we call malignant. So a benign tumor should be, when you look at it with your naked eye, should be encapsulated, and it will grow slowly, and it is non-invasive, meaning it does not invade into adjacent tissue or organs, and so it's limited to the tissue planes around it. Tend to stay localized and is well differentiated. What do we mean by differentiation? تعرفوا ايش معنى كلمة differentiation؟ Resembling what tissue? Resembling normal tissue, okay? So the more a tumor resembles normal tissue, the more it is well differentiated. The less it resembles normal tissue, then the less well differentiated. So we call it poorly differentiated, okay? So malignant tumors is the ones we call cancer. So when you hear the word cancer, cancer means malignant tumor, okay? Can invade and destroy and can spread to other sites. فبالتالي هيكون unencapsulated, they are fast growing, they grow faster than compared to benign. They are more invasive. طبعا انت لما تقول fast versus slow, what defines fast versus slow؟ ما حقيقة الأمور هنا is relative, okay؟ فمقارنة الشيء بالشيء. And malignant tumors are fast growing because they proliferate rapidly, okay? And they do not recognize the limitations of respecting neighboring cells or neighboring tissue. So they grow fast and they invade. They can also have ability to metastasize. Can be ممكن تكون well differentiated. They can be moderately differentiated or poorly differentiated or anaplastic. And what do we mean by anaplastic? أحد يعرف إيش معنى anaplastic؟ anaplastic يعني ما هي شبه أي normal tissue. Okay, so you cannot tell if you look at this tumor, is this tumor trying to look like lymphoid cells, like sarcoma, like carcinoma, like epithelium, like anything, okay? So it's just cells that have ugly appearance. They don't look like anything. It's like a monster. It's like a monster that you've seen in a horror movie. It doesn't look like anything. Okay. تكلمتوا عن nomenclature of tumor. هل كلموكم عليها؟ على أي أساس نسمي tumors؟ Okay, I'll skip it. Okay, تكلمتوا على classification هذا؟ Good. طيب إيش الفرق بين إيش معنى أدينوما؟ أدينوما إيش معناها؟ لما نقول على تيومر إنه أدينوما فأنا إيش أقصد؟ Okay, benign tumor of epithelial origin, yes. And this benign tumor of epithelial origin, it forms tubules, tubular structure. So it forms benign appearing glands. Okay, عشان كده نسميها أدينوما. طب إذا كان vascular tumor إيش نسميه؟ angioma. ممتاز. ممتاز. Okay. طيب malignant tumors depend on the type of tissue they are trying to resemble. So اتكلمتوا عن تعرفوا الفرق بين الكارسينوما والساركوما؟ Okay, epithelial versus connective tissue. Carcinoma means in a tumor is trying to resemble epithelial tissue. Sarcoma means tumor is trying to resemble connective tissue. بكل أنواعه. طيب أمثلة على squamous cell carcinoma، أمثلة على الكارسينوما، squamous cell carcinoma، adenocarcinoma. طيب سؤال، إيش الفرق بين الأدينوكارسينوما والأدينوما؟ إيش وجه الشبه بينهم معنى ثاني؟ Okay, one is benign, the other one is malignant. Both are epithelial origin and both are what? What do they form? طب ايش الفرق بين squamous cell carcinoma و adenocarcinoma؟ Excellent. Glandular structures. ممتاز. Glandular structures with what? With adenocarcinoma. Squamous cells with squamous cell carcinoma. Okay. طيب اتكلمتوا على هذا الجيرم layers. Yes. So teratoma, what does teratoma represent? What is teratoma? What is teratoma? Okay, so it represents, it's a tumor that represents tissue from all three germ cell layers. Not many, three germ cell layer. Okay, هتلاقيه تيومر لكنه خليط من عدة أنواع من التيشوز. Okay, هتلاقي طبعا with varying percentages. skin أو gastrointestinal tract أو respiratory tract أو renal epithelium. Okay. Teratoma, you think teratoma is always malignant ولا benign؟ هنا لأنه مهند بيقول malignant. Are all teratomas malignant or benign؟ هحط لكم سؤال ابغاكم تجاوبوه. ابغى اشوف ارائكم. باقي اثنين بس جاوبوا. Okay, either way we'll answer. So majority of the answers are saying malignant and only one said it's benign. طيب, okay, let's go. طيب, okay, when you talk about teratoma, so by definition كلمة teratoma لوحدها doesn't mean benign or malignant, although معظم الحالات معظم الحالات التيراتوماز are benign. اوكي. متى تكون benign التيراتوما؟ لما تكون consist mostly of mature tissue. mature يعني adult type tissue. اوكي. طبعا هذا في حالة الفيميلز، في الومن. لو التيراتوما فيها immature tissue، بمعنى tissue that resembles fetal tissue, this is called immature teratoma. يعتمد على amount, the extent of the immature tissue. And the immature teratomas are considered malignant. Okay? They are considered malignant. Okay? So in males, the behavior of teratoma will depend on the age. Okay? So in post-pubertal age, teratomas of the testicles will behave in a malignant fashion in post-pubertal or adult. But in pre-pubertal testicular teratoma, they behave benign. خلاص؟ عرفتوا التيراتوما الآن؟ فالتيراتوما كلمة تيراتوما لوحدها doesn't mean it's benign or malignant. If you say mature teratoma, it is benign. If you say it is immature teratoma, it is malignant. Okay, clear? So let's go on. طيب هذا الجدول، خلصتوا الجدول الفرق بين اوما وكارسينوما؟ تحتاجوا اعيده ولا اسالكم عليه شيء ولا خلاص that's it؟ I'll go to the next one. So this is about mixed tumors. Mixed tumors على سبيل المثال اللي هي neoplastic cells are monoclonal, لكن they show divergent differentiation. So they diverge into epithelial and connective tissue at the same time. أمثلة عليها pleomorphic adenoma, benign mixed tumor of salivary gland اللي هو pleomorphic adenoma, the other name for it, and fibroadenoma of the breast. Okay. طيب هل في malignant counterpart للتيومرز هذه الميكس تيومرز؟ يس، مثال عليها الفيلويدس تيومر. اوكي. طيب هنا تكلمنا على الجيرم سيل تيومرز، على التيراتوما. You already discussed this. طيب هنا characteristic of benign malignant tumor خلاص عديتوا عليه. اوكي. Differentiation. Did you take differentiation or you want me to review it? Took it. Okay, next one. Differentiation. Well differentiated, moderately, and undifferentiated. خلاص ولا took it? Anaplasia, ruse, metastasis. Okay, stop me where, just tell me when to stop, okay? Okay. So okay, this is 3 and 5. هنا أخذت الأونكوجينيسيس oncogenes وtumor suppressor genes, initiation and promotion. اوكي، نروح للي بعده. molecular bases تكلمتوا عليها اكيد. accordingly هذه 4 lecture 4 هذه اخذتوها؟ yes no ولا no yes؟ اوكي. so هنا lecture 4 نتكلم على الخصائص، the characteristics that allow a tumor to survive, grow, and have the ability to invade and metastasize. Okay, so the first one is self-sufficiency in growth signals. Number 2 is insensitivity to growth inhibitory signals. فاكرين وتكلمنا أول على الجروث فاكتورز وعلى الجروث inhibitors لما تكلمنا على الهيلينج والريجنريشن. So now we talk about them also in the setting of neoplasia. The third characteristic is evading of apoptosis and genes regulating apoptosis, limitless replicative potential, sustained angiogenesis, and ability to invade and metastasize. Okay? هنتكلم على كل واحد منهم. So normally أي cell needs growth factors to remain alive and to maintain its growth. Okay, and these growth factors and their receptors and the pathway within the cell are encoded by genes. In the normal setting, we call these genes proto-oncogen. Okay, if these genes undergo mutation, we call it oncogen. فالبروتو-oncogen متى ما صار فيه له mutation اتحول لأونكوجين. اوكي، لايك لما يكون عندك لايت سويتش، واللايت سويتش هذا شغلته ينطفي ويقفل، وفجأة يخرب اللايت سويتش هذا لأنه الجين that codes for this light switch is mutated and this light switch remains on all the time. وقتها اتحول من بروتو أونكوجين لأونكوجين. Oncogens will translate into oncoproteins. Okay, oncoproteins are the product of oncogen, and they have abilities, and they have these abilities that in the end induce uncontrolled proliferation of the cell على عدة صعد. الصعيد الأول إنه كمية الgrowth factor that's produced is uncontrollable، أو إنه الريسبتور للgrowth factor is either overexpressed or إنه mutated. Okay, once it's activated it does not become deactivated. أو إنه يكون في mutation for a gene that codes a signaling protein ينقل الإشارة من الريسبتور للنيوكليس. أو إنه يكون في overexpression of nuclear transcription factors that controls the cell cycle. فاكرين السيل سايكل؟ أول تكلمنا على السيل سايكل وأنواع السيلز لما تكلمنا على الريبير والهيلينج. أو إنها بتكون في الأخير أنواع من أنواع الأونكوجينز اللي هو mutation in cycling genes، وهذه cycling genes are important in controlling the cell cycle. Okay؟ فهي يا إنها شيء related لmutation في الجروث ريسبتور أو في الريسبتور للجروث فاكتور، يا إنها mutation في الجروث فاكتور يا mutation في الجروث فاكتور ريسبتور أو signaling pathway أو nuclear transcription factor or cycling. هذه أمثلة just to show you. So stimulus independent of secretion of growth factor will start cell replication. مثال عليه platelet derived growth factor، وهذا مهم في البرين tumors. Mutations that lead to overexpression of growth factor receptors، وهذا مثال مهم جدا اللي هو breast cancer اللي هو HER2 new receptor. Okay, and why are these important? Do you know why we're talking about these receptors? Why do they have practical implication ولا هو بس research ولا إنه yeah, excellent for targeted therapy, and they are becoming more and more important because now we're able to design molecules that have the ability to block certain receptors. Okay, so مثال عليها drug named تروتزماب. اوكي، طيب نيجي بعد كده للراس. طبعا في بعض الميوتيشنز اللي موجوده على سبيل المثال الكيراس mutations are susceptible to more types of treatment than others, so also important for targeted therapy and for selection of patients for treatment. Other gene encoding for receptor signal is ABL tyrosine kinase. ABL tyrosine kinase اللي هو very important to know, you will keep on hearing about it، اللي هو الفيلادلفيا chromosome يسموه، اللي هو result from translocation between BCR able and involves translocation between parts of chromosome 9 and chromosome 22. The importance in the fusion that results from this translocation in chronic myeloid leukemia can be targeted by a drug called imatinib. Okay, and patients have good response on imatinib. Prior to imatinib, the treatment of chronic myeloid leukemia was very, very difficult, and the patients Okay, معلش شباب بس can you give me a second please? Transcription factor that promotes cell cycle. مثال عليها الميك جين. الميك جين very important when you talk about Burkitt's lymphoma. And Burkitt lymphoma has characteristic translocation between chromosome 814. Okay, and fifth, mutations that activate cycling genes. مثال عليها اللي هو CDK cycling. هتقولوا لي طيب نحن ايش مفروض هل نحفظها كلها؟ لا انت ما حتحفظها كلها، انت اهم شيء تعرف الميكانيزمز. Most important is that you know the mechanisms. You know the mechanisms and you just know one good example of each category. That's all you need to know. Okay, you don't have to memorize each one of these. Okay, so sufficiency in cell growth signals. Next is insensitivity to growth inhibitory signals.
دكتور معليش ما نقدر نشوف السلايد.
طيب الآن خليني بس شوف لا ما في مشكلة. المشكلة قد تكون في why is it screen sharing? Okay, how about now? الآن؟
تمام شكرا لك.
ما في مشكلة. طيب. Okay, let's go back. So الآن a second ability اللي تكون موجودة في neoplastic cells إنها able to become insensitive to growth inhibitory signal. فالgrowth inhibitory signals موجودة في السيل as a mechanism كأنها بتنبه السيل إنه to stop growing and the cell has to listen to this order. So one of the second ability for the cancer cell is that it does not listen to growth inhibitory signals. And growth inhibitory signals are encoded by genes that we call tumor suppressor genes. Okay. طيب انت علشان تفقد الفانكشن the growth inhibitory function you need to lose 2 copies of the gene. Okay. So losing 1 copy is not enough. But if you have let's say نقارنها بالأنواع الأولى اللي كانت في الgrowth factor. If you have mutation of 1 gene, it's enough to express tumor. Okay, لأنه the cells will grow faster and faster and faster. However, if you have the tumor suppressor gene, mutation of 1 gene is not enough. You need to have mutation of both genes. Okay, وهذا مهم فين؟ مهم في الناس اللي هم يتولدوا without a tumor suppressor gene, without 1 copy of the tumor suppressor gene. So what will happen? These patients who have familial deposition for cancer, predisposition for cancer, are born with defective copy, okay, with 1 defective copy. And the other copy is intact, it's normal. So what happens during life? The other normal copy undergoes mutation and then they develop cancer. Okay, أمثلة عليها retinoblastoma gene. And these patients, what they have من اسمه, they develop retinoblastoma, they develop eye tumor in a young age. Okay, so these can be لما تسمع كلمة familial وsporadic, familial بمعنى إنه هو أصلاً اتولد وعنده نسخة missing, deleted من التيومر سبريسور جين وعنده واحدة نورمال. Okay, sporadic, what do we mean? We mean إنه he was born with both normal alleles but they got lost later on in life which resulted in cancer. Okay. طيب familial predisposition to develop tumor is transmitted as autosomal dominant trait. بعض الجينز so are transmitted as autosomal dominant trait لأنه you need to lose get one copy that's lost from one of the parents who was lucky enough and they didn't have mutation of the normal copy they were living with, but they gave the abnormal missing copy to the child, which child was unlucky and undergone a second mutation وجاء عنده الكانسر. Okay. طيب P53 very important to know about. It's one of the most common mutated genes in human cancer. لكن ما هو specific لنوع كانسر معين. Okay. The other one is adenomatosis polyposis coli APC gene, which is a tumor suppressor genes lost in colonic adenocarcinoma, especially those with a disease called familial adenomatous polyposis. دقيقة. طيب خلاص بدنا نحرك افتح الباوربوينت خلاص بدأ كينوت طيب بس افتح الكينوت هي باين سريع الحين حيكون باين حطي لها بس حطي لها فول سكرين بس. Okay, so كان على ال APC. Okay, next نيجي للسيل سايكل and just to understand عشان ليش نحن حاطين السيل سايكل عشان نفهم الرول of transcription factor and the role of cyclins. طبعا اتكلمنا على الفيز of cell cycle اول قلت لكم انه في اول ما السيل بتتولد بتدخل في الجي 1 فيز واذا دخلت في الجي 1 فيز لازم تكمل السايكل هذه كلها، ما تقدر السيل تقعد في فيز واحد خلال السيل سايكل الا في حاله واحده انها تروح للجينات. اذا راحت للجينات خلاص صارت ستيبل سيل ما بتعمل proliferation. Okay, so if the cell goes and during each one of these phases the cell is controlled by transcription factors and is only allowed to go to the next phase after after certain precautions. Okay, انت لو عندك سيل تبي تروح من الجي 1 للاس فيز، السيل بتجهز الماشينري هنا and بتجهز الريسورسز، بتجهز الاندوبلازميك ريتيكولوم، بتجهز الدي ان اي، بتجهز كل شيء عشان ايش؟ to be able to enter the S phase اللي هو التصنيع، تجهز نفسها لتصنيع الدي ان اي. اوكي، تصنيع الدي ان اي. بعد كده في الجي 2 بتحاول تجهز نفسها للميتوزيس. اوكي، فخلال المرور from each one of these phases of the cell cycle في certain requirements the cell has to fulfill before it's allowed to go to the next one. Okay, the control of the cell by transcription factor that allows it to go from G1 to S phase is controlled by the retinoblastoma gene. Okay, وفي others هنا حط عليهم pointers، لكن الفكرة الرئيسية إنه أنت تبي تتأكد إنه السيل ما does not complete the cell cycle. It has to complete the cell cycle with okay. دقيقة بس أقفل. معلش can you give me just 2 seconds? Sorry.
ايوه
اذا تحبي ممكن ترسلي لي اياها على الواتساب واحاول انا اعرضها من عندي.
لا دقيقة بديت حل. كده باين عندكم؟
دقيقة. اوكي ثانك يو. خلاص كده. Okay, sorry, I'm back. So we're talking about So cells prepare for DNA synthesis is extremely important. ليش؟ انت بتتاكد السيل ما تخرج مثلا من الاس فيز لل G2 وما تروح من الG2 للM phase with any mutations or abnormalities in the DNA. Okay? لانه انت ما تبغى الميوتيشنز هذه تكون موجوده في السيلز that are born from this mitosis. this is more or less like a spell correction mechanism. السيل اللي ما تقدر تصلح الميوتيشن اللي فيها it will be given chances to repair this damage, but if it cannot repair this damage, then apoptosis will be activated and the cell will commit suicide. Okay. طيب نيجي هنا لل P53. Why P53 is important? Because P53 has this name كأنه واحد comic characters, guardian of the genome, and it is a guardian of the genome by action of its tumor suppressor function, which is encoded by tumor suppressor gene, and it has a very important role in maintaining integrity of the genome. Okay, so what it can do, so it senses, it has a sensor for DNA damage. And when it senses DNA damage, it will order the cell to stop progressing through the cell cycle, and it will arrest it in the G1 phase and allow the cell to induce DNA repair genes. Okay, so the types of arrest that can occur as a result of the inability of the cell to repair P53 is by either one of these three mechanisms. Okay, ففي الأول temporary arresting of cell cycle, and then permanent arresting of cell cycle, and third والحل الأخير اللي هو final solution is triggered active programmed cell death. هذه نسميها phases. نسمي في phase الأول اللي هو quiescence الخمول، senescence انه زي لما احد يكون سيناعي لو كبير في السن، فخلاص هذه السيل arrested in the cell cycle وحتقعد arrested محبوسه في السيل cycle forever. Okay, until it undergoes apoptosis or it stays there. Okay, until it dies. طيب في syndromes, let's think what can happen if a person loses both copies, inherits or inherits one deleted copy of P53 from their parents, or inherits both deleted copies of P53 from the parents. يصير homozygous loss. ايش اللي حيحصل؟ انه يصير عندهم syndrome called Li-Fraumeni syndrome. And this Li-Fraumeni syndrome predisposes the patient for many types of tumors all over the body. منها على سبيل المثال osteosarcomas in the brain, and also, osteosarcomas of the bone. They are also predisposed to develop glioblastoma, highly malignant brain tumors, and also other tumors. Breast cancer also, they're predisposed to develop breast cancer in addition. So many types of cancer can occur. Okay. So this illustrates a function of P53. فهنا جايب لك وجه normal P53 function. شوف كيف السيل مسوية وجه مبتسم هنا. So DNA damage happens, and then so P53 is activated, binds to the DNA, the P53 protein, and then it starts to control the transcription factors through these mechanisms. So it induces repair of DNA, and if repair does not happen, induces apoptosis. So this is the situation where P53 is intact. Where P53 is mutated, you see cell damage will result in formation of neoplasm, of tumor. Okay. So genes, so evading, the third feature of neoplastic cell is evading apoptosis.